Hi everybody, welcome to another video in Math 1332, section 12.1, sampling, frequency, distribution, and graphs. So in this chapter we study about statistics. Statistics is a branch of mathematics deal with collecting, organizing, summarizing, representing data. And we just go over briefly the very brief part of statistics. So we have descriptive, we describe things, and inferential statistics, raw conclusion from the data. And talking about data is the measurement or observation gathered for an event under study. Right. Now, more importantly, population is the whole thing, so that will be all people, object to be described and analyzed by the data collector. The sample is a subset or the subgroup of the population, so sample is smaller. For example, if we talk about everybody in US, that's the population, and if before an election we want to see how certain people vote some certain way or what the result is going to be, we survey 6,000 people across the country, for example. That 6,000 people is a sample, and very important that the sample has to be representative of the whole data, or otherwise it will not do any good if you choose a sample that does not represent the population well. Right, here's some example. A group of hotel owners in a large city decide to conduct survey among citizens of the city to discover their opinion about casino gambling. Describe the population. So we will have the citizens of the large city. That is the population. Next, one hotel owner suggests obtaining the sample by surveying all the people at 6 of the largest nightclubs in the city on a Saturday night. Each person will be asked question. Now, does this seem like a good idea? By the way, we know the population is the citizen of that large city, so everybody in the city. Now, is that a good idea to choose a sample like this? And the answer to that is no, because if you want to ask everybody, have to be representative of the whole community. If you ask the people that at the nightclub on a Saturday night, most likely they will favor the casino. But if you ask for the children, the school teachers or others people like the church people, for example, they will oppose the casino gambling. So if you choose the people that tend to favor the group of casino gambling, that is not a good idea to have to gather the data like that, or to gather the sample like that. So the answer is no. Yeah. The sample does not represent the population well. Right, next, a random sample is a sample obtained by such a way that every element in the population have the chance of being selected for the sample. Equal chance. So random sample is equal chance. The method we identify each element in the population, assign a number, and then choose a number randomly. Right. So if we want the population, if we want the sample to be represent the population well, the sample have to be done kind of in a random sample, in a random way. So the sample will represent the population well. Right, here's some example. Which of the following best way to random sample to find out how the city citizens feel about casino gambling? Right, survey people who live at the oceanfront condos. That's not a good idea because, like I said, that kind of geared towards some certain part of the population. Survey the first 200 whose name appear in the city telephone directory. That's actually not bad. but randomly select the neighborhood of the city and then randomly survey people within selected neighborhood. So the last one is truly simple because it's a better sample because the way we choose randomly, everybody will have a chance to be selected randomly. So this will be the best. Right. Next, rather than the random sample, there are other ways to select the sample. So we talk about random sample. Now the systematic sample is which we select, assign each number of the population and select every K member. So this is a systematic sample. Or than that we have stratify, cluster, and cluster. A cluster is divide the population is used, for example. And then when stratified, a population divided into groups with similar characteristic, and then member with chosen at random from the group. And the cluster represent the population is used, and then with this the cluster is we choose the whole group. So this is different between the cluster and stratified. Cluster we choose the whole group, where stratified we choose some of each group. Right. I took some example here. Identify the type of random sample. 35 math major, 29 music major, and 26 history. I select them from the subset like this. What sampling technique is this? So first of all, this divide into groups. So it's either stratified and cluster. Now we don't choose the whole group. We choose some from each group. So this is called the stratified. We choose some for each group. Stratified. At the local technical school, 5 auto repair classes are randomly selected, and all of the students from each class are interviewed. What sampling technique is this? We do see the all of the students from those classes. So we divide into a bunch of groups, and we choose a few groups. But when we choose a group, we ask everybody, every member in that group. So that is called cluster. Yeah. We choose all of the students in the groups. So that is cluster. Right. Next, the names of 30 employees are written on a card, and the cards are placed in the back, and 3 names are picked from the back. What sampling technique is this? Well, we have 30 people, 30 names on the cards, and we pick them at look like random because each of them will have the same chance of being selected. So this is just a random sample. And then next, every fifth of entering the airport, we don't have to go any further. That's good enough. Every fifth, that is systematic sample. And the travel industry researcher interviewed all of the passengers on 5 random selected groups. Once again, all of the passengers in the randomly selected groups. So this is cluster. So that is how do we choose the sample to represent the data well. Now that if we have the data, this is how we describe the data. 25 volunteers, whatever the data we have is the raw data. We have to somehow organize that so they would give us something, would tell us something about the picture of things. Right. Now, in that case, 25 volunteers for medical research were given a blood test obtained in their blood time, and this is what we have. Construct a categorical frequency distribution. So this is pretty much 4 types of bloods. So type, then we have frequency. Right, the A, B, AB, and O. Right. A, how many we have? 1, 2, 3, 4, and 5. Yeah. The frequency is just a fancy way of saying how many on each category. Then B, 1, 2, 3, 4, 5, 6, 7. And then AB, 1, 2, 3, 4. The rest are O. 1, 2, 3, 4, 5, 6, 7, 8, 9. And just make sure we add them 13 and 12, 25. So that's good. Yeah, so that frequency distribution, we just list how many we have on each category. Right, next, construct the frequency distribution for the following data with 8 minimum year growth for boys. What are some conclusions based on this sample? Right. Look like from here we have anywhere from 12 to 18. Yeah. So the data of maximum yearly growth. So this is give us year and give us how many we have. Right. Looks like the smallest number is 10. After that is 12. 1, 2, 3. And now 13. 1, 2, 3, 4, 5. Uh, 14. 1, 2, 3, 4, 5, 6, 7. And then 15. 2, 3, 4. And then 16. If we forgot a 15 here. So 1, 2, 3, 4, 5. Now 16. 16. 16. 2. 17. 1. 18. Also 1. Right, look like we underline everything, cross out everything. So that's what we have. This is 1, by the way. So So what we see here is the time that I'll have the maximum growth rate in boys is around here, where it occur the most. Right, so the frequency. So that's good if we just count how many we have here. But usually we might want to group them in more meaningful ways, especially the data when it's too much like this. If we just group them into each one individually, it's not going to be good. So we have to group them in range of numbers. So let's say we have the lowest here look like 47 and the highest is 94. So with that said, we should divide into the group of 10. And the way we write this, I set the lowest in the 40, so we say 40 to 49. 50 to 59, 60 to 69, 70 to 79, 80, 89, 90, 100, 90, 99. Okay, so divide that into a group of 10 like this, right? Now just tally. Just tally pretty much. 82, 1, 47, 75, 64, 57, 82, 63, 93, 76, 68, 84, 54, 88, 77, 79, 80, 94, 92, 94, 80, 'If we close out, we mark the wrong box, right? Right. '93, 94, 92, 94. Sorry, put the wrong one. So up to this point, 1, 2, 3, 4. All right, 80s. 1, 2, 3, 4, and 5. Right, that's good. Sorry. 70. 1, 2, 3, 4. Right, 60. 1, 2, 3. 1, 2, 3. Right, only 3 now. 50, 59. 1, 2, right? 40, 49, 47. Yeah, this one, right? Keep going. 80, 94, 66, 81, 67, 75, 73, 66, 87, 76, 45, 45, 43, 56, 57, 74, 50, 78, 71, 80. Just keep marking the wrong one. That doesn't work. Switch to different colors. Okay, let's count how many 40s we have. 1, 2, 3. Good. 50. 5. 60. 3, 4, 5, 6, 70. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That's right, 11. 80. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, that's 8. Is that correct? There's an extra 59 there. Good. And then 90s is what? Oh, an extra 88. And what's left is 99. 1, 2, 3, 4, and 5. Yeah, so yeah, that pretty much work out how many we have in this case. Right, let's see. Let's write 3. That's 7. If I can count 6, 3, 6, and 6, 11, 9, and 5. Add all of them up. That's 26 and 6. That's 12. 3, 15, 15 and 5, 20, 11 and 9, 20, 20, 40. So 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4. Yeah, so that's 40 total. So it's good. Always check the total. Make sure that we actually count everything. Right, next. Next we'll draw some of the graphs. So, draw the bar graph using the blood type in page 110. Right, this is the blood type. And the bar graph, we just have the bars of column. Right, so let's say it. Just draw the bar. The smallest number is 7 and the highest smallest number is 4, the highest is 9. So let's say it. 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? The 8, just make a column. For 8 is 5. 1, 2, 3, 4, 5. B is 9. B is 7, sorry. AB is 4. And O is 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we just have 2, 4, 6, 8, 10. And they said blood type. Always name the graph so we know what we're talking about. Right. So distribution, or we say frequency distribution for blood type. That's what we have. Next. So that is the bar graph, just for bars of data. The higher the bar, the more of that data in the data set. Next, use the draw the polygon for the data of the test score on page 111. So we're going to use this. And notice that the group will be from 10 each. But the frequency polygon is a little more complicated. So we have to prepare the x-axis first. Right. So we have 40, and we don't write 49, we just say 50, just the lower class limit. And then we have to use the midpoint, and corresponding to the midpoint is the height. So first there are 3 here, so that is corresponding to 40 to 49. By the way, this is the data. I'm just going to put that aside. Next, 50 and 59, that will be between here and going to be 6. And then 60 and 69 also 6. Just for the midpoint of this each class here. 11 for 70s. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And we don't draw the little dot like this, that's really confusing. And then the 80 to 89, that would be 9. And 90 to 95 is 5. So just connect them. So this is called the frequency polygon. But one thing, we have to draw the midterm on the next. Just connect that to 0. Right. 2, 4, 6, 8, 10, 12. So that is called the frequency polygon. So instead of drawing the graph, now this data is different. This data we have numbers instead of blood type. So that type the numbers, so we can have, we only have the numbers increasing. The blood type we can scramble the columns. It doesn't matter. But in this case we have to have in the right order, and so we have to use the midpoint as a polygon, and then at the end we draw that to the end points. So next, the stem and leaf. The stem and leaf using the digit on the rightmost to be the the leaf, and then the one on the left is going to be the stem. Right. So in that case, and after that we have to put them in increasing order. Sometimes like this it is easier to describe. So let's say we split the data between the ones and everything above that. So we have, I'll draw a line here. Look like the smallest is the 80, and then the 86. And after that there's 90. We split. And we write the ones for the leaves, the other one is the stem. And then 100. (106). And now the 111, or 110, I mean. 1, 2, 3. Every time we count, we write the ones place. 4, 3, 1, 1, 5, 7. And then the 12. 122, 123 3 times. And what's left is the 131 by itself. Yeah, so we write the one place and everything above the one place to be the stem. After that, we can draw again, but this time we have to rearrange them. So the leaves will be in increasing order. Six, 0, 0, 0, 6. Now for this we have to put them. Wait, there's 3. Okay, never mind. I'll just count them. Have to be increasing order of this. So 1, 1. 2, 3, 3, 4, 5, 5, 7, and 9. And then the 12 we have 2, 3, 3, 3, 131. Right. To denote that, we say 90 equal to 90. So we have to write that to denote that. How do we describe the stem and the leaf in our problem? So those are some of the graph, the type of graph that we have. Notice that there is the deception when we use data. Here's some example. Is that whenever we graph, if we use the pie chart, use the 2D, don't use the 3D, because in this case, the one on the back here, and that kind of misleading that they are equal, but actually they are not. So the 3D create the deception to it. And the rest of the section, we talk about the things that we need to watch out for if we want the data. Both of these graphs describe the same data, but one of them, the one on the left, stretch the scale vertically, create that the graphic growth of poverty rate, although it did not actually increase as much on this graph. And then those are the things that we need to watch out for. If there's the title, explain what being displayed, yeah, there should be a title, number, all of that. So I said, this is in the notes, so I'll let you read that. But other than that, we finished section 12.1. Thank you for watching, and see you in another video in Math 1332.